In the last video, we looked at this first option right up here for how to approach combined work questions. In this first option, we said, well, we can just add the individual rates to get the together rate. In this video, I want to look at a second option for these combined work questions, and we're actually going to derive it from this first option. We'll derive sort of a shortcut formula that's pretty useful for a lot of GMAT combined work questions. And to get from here to our shortcut formula, I want to use this little example here. Alice can do a job in A hours. Bob can do the same job in B hours. How long would it take Alice and Bob working together to do the job? Well, if we start with our add the rates method, well, our goal is then to get the rate of Alice, to get Alice's rate and add Bob's rate, and that will lead to our combined rate, the rate of them working together. So what is Alice's rate? Well, she does a job in A hours, so to turn that into a rate, if we're not certain, we can go back to our little combined, our little, that's an ugly triangle, our little mnemonic triangle here for work, rate, and time. Work on top, rate, time on the bottom, and that can remind us, well, rate, that is going to be work per time. Rate is going to be work over time. So Alice's rate is going to be how much work she does per how long it takes. And we know how long it takes. We're told that she takes A hours, that's our time. But how much work does she do in those A hours? Well, here I just say Alice can do a job, so one job. So the work she does in A hours is one job in A hours. Similarly, Bob's rate is one job in B hours. And altogether, we're trying to find, well, how long it'll take them working together to do one job. And so the rate then would be one job in the together time, the time for them to do that one job together. So that's just plugging into our trusty add the rates method for combined work. So our job in terms of answering this question and in leading to the formula that this video was all about is going to be to solve this thing for t, right? That t represents time to do that single job together. So we've got to do some algebra to this to isolate t. All right, how are we going to do that? Well, I guess what I really want to do is take the reciprocal of this side of the equation, so I have not 1 over t, but to have t over 1. But I can't do that directly here because I've got 2 fractions rather than just 1. So what I want is to turn this into 1 fraction. And I can't quite do that yet because my denominators are different. I can't add these fractions yet. So how do I get the denominators the same? Well, I'm stuck with an a in one and a b in the other, so I guess I'm going to have both a and b in our common denominator. So I'm going to multiply this first fraction by b over b. And I'm going to multiply the second fraction by a over a. Let's see what that does. Our first fraction becomes, multiplying the numerators, b times 1 is b. And the denominators, b times a is ba or ab. Plus our second fraction becomes a over ab. And all of this still equals 1 over t. So now I have my common denominators. We can add the numerators to get b plus a over ab equals 1 over t. And now we can do what we wanted to do originally. Now we've got a single fraction over here, a single fraction over here, so we can take our reciprocals, and I'm gonna change to white to do this step because this is the formula that we've been building up to. If I take the reciprocals of both sides, I get ab over b plus a, or if I reverse the order, a plus b, all equals the reciprocal of this is just t. And, well, that is the answer to this question. How long does it take them together? Well, we said this T represents the time it takes to do one job, and then we isolated and said, well, together would take them AB over A plus B. But I also want to get that formula down because it is a pretty useful shortcut formula for a surprising number of GMAT combined work questions. So rather than going through this whole process the whole time, it's nice to have easy access to this well, we can call it, I don't know, let's call it, what we would call this, we call this combined work option number 1. Let's call this combined work option 2. Option 2. That's not to suggest that, the one is better than the second one, just that we've got a couple of options. So this is combined work option 2, a useful formula, can make quick work of quite a few questions. But I want to make sure we sort of keep the logic of this formula. I want to make a couple points about that formula. First, we'll call it combined work option 2. That's fine. Also note that it's actually not as versatile as our general option, because this is actually only for 2 workers. You could derive one for 3 workers if you wanted, although I've rarely seen questions in which that's useful. So keep in mind that this particular formula really only works for 2 workers. And finally, as with all formulas, we've got to keep in mind exactly what these variables represent. We started with the rates, and then we said, to get those rates, we said, well, Alice can do one job in A hours, and Bob can do one job in B hours, and together the rate is one job in T hours. So each of these variables, A, B, and T, every variable represents time. Every variable represents time to do the same job. And that's important. That's how we'll recognize questions for which this formula is very useful. If we're given one worker's time, another worker's time, and we're asked for the combined time, then we can make quick work of the question with this useful combined work option number 2 formula. So let's see. Let's take a look at an example. I think I've got one down here. There it is. All right. So actually, I recommend you pause the video and see if you can apply the shortcut formula we just looked at to this question. Apply this nice shortcut formula to this. All right. So I assume you've paused the video and given this question a try. Let's take a look. Susan can paint a room in 4 hours. Beth can paint the room in 5 hours. How long would it take the 2 of them working together to paint the room? Well, what are we given? We're given time for one person to do a job. We're given time for another person to do the same job. And then we're asked for time to do that same job. So this is exactly the scenario for which our time to do the job for 2 workers formula will be very helpful. So our formula, the combined time to do the job is the product of the individual times to do that job over the sum of the individual times to do that job. And in this case, we've got combined time is going to be, well, let's see. Susan's job is 4 hours. Susan's time is 4 hours to do the job. Beth's time to do the job is 5 hours. So we've got 4 times 5 over 4 plus 5 equals 20 over 9. Or for this question, that leads to answer choice C. So you can see that question, this particular question, we could solve in really just a few seconds with that nice shortcut formula, which we will call combined work option number 2.